This MOOPIL series of Texas A&M University is provided through Project LISTO. Literacy-infused science using technology innovation opportunities. The video series is comprised of experts in the field talking about their research while making important contributions to the art of teaching in the K-12 environment. Project LISTO is funded through a competitive I-3 grant from the U.S. Department of Education Investing in Innovation program. The LISTO project is a collaboration among the Center for Research and Development in Dual Language and Literacy Acquisition, Education Leadership Research Center, and Aggie STEM.
Howdy, my name is Rachel Yujin Lee. I'm a PhD student in mathematics education at Texas A&M University. My research focuses on STEM education. I have been teaching microcontroller in the Aggie STEM summer camp to the middle and high school students. The students learned microcontroller and coding, which was highly related to the microcontroller. In this video, I'm going to talk about microcontroller and how it can be used in the class. Have you heard of the microcontroller and are wondering what it is? A microcontroller is an integrated circuit that is basically a tiny computer. You can find the microcontroller in all kinds of devices, such as television, microwave, refrigerator, and cell phone. The microcontroller is used for embedded control in virtually every field of science and engineering. Exposing students to the activities using the microcontroller can be an engaging and effective way to foster the academic performance and motivation toward STEM-related fields they will need in a global competitive workplace. To teach microcontroller in my class, I used an Arduino. The Arduino is a circuit board that has the microcontroller chip on it. There are a lot of different types of Arduinos, and I used the Arduino Uno, which is one type of Arduinos and good enough for most projects for my students. The Arduino Uno can be programmed to do many different things by making circuits and using the codes. You can use it to control motors, lighting, cameras, or even build a simple robot. For instance, you can read information from sensors. If you want the board to read what the temperature is in your room, you can use the temperature sensor, which is sensitive to temperature.
Whoa, Tanner, his got up to like 87. 88.
Dude, plug those wires in? Yep.
89.
Let me see. It was working earlier. Alright, was working? Alright, sweet.
Can you get up to 90? Will he get to 90?
As you can see on the video, you need the Arduino hardware as well as the Arduino software. You need codes to make the Arduino hardware works. A microcontroller is typically programmed in high-level languages, such as C++ or Java. But the Arduino company provides the Arduino software that students or the beginners can easily use. The Arduino software is open source, meaning anyone can contribute to the growing pool of resources available to its users. If the Arduino hardware and software are ready, you can connect the Arduino hardware to your computer with a USB cable. Open the Arduino software, choose the proper codes, and run it. Through the microcontroller activities, students would become more familiar with key concepts of electricity, circuits, components, and coding. Students will create circuits by plugging electronic components such as LEDs and other components into their breadboard. These activities introduced each new component with a basic exercise showing the students how to wire it up and how it works. You also can make vocabulary matching cards to help the students' understanding. Matching the picture cards with the word cards helps the students reflecting their understanding about the components. While the students add buttons and knobs to control their circuits, they will also learn how the circuit works and programming concepts. Students use the Arduino software, which includes the codes make their Arduino hardware works. In the video you're going to watch, the students were doing Arduino activity. They made a single servo circuit and are trying to change the speed of the servo.
Here, it should change.
Yeah.
There we go.
I'll put your finger on this. See what your body temperature is.
And change
You
it.
need to upload it.
Alright, now let's upload it.
Well, to verify it, you
You don't need to verify it. Oh no, I made it too slow. Alright.
Speed it up. Should be around.
Alright, putting more zeros made it slower. Unexpectedly slower. So let's
Mine is like 87.
put it all at 10. It's gonna be really fast.
As you could see on the video, students changed the numbers in codes to see different output of the servo. Like this, students experienced the interaction between Arduino hardware and software. They also can connect their mathematical knowledge with coding and microcontroller. The microcontroller activities are implementing computer science in the classroom. Students can develop STEM-related skills.